my name is Siyabonga Zwane, your tutor for both PYC1501 and PYC1502. Last week, we were discussing human nervous system, but specializing in neurons and synapses. The first chapter, neurons and synapses. I decided to break the chapter into two. Human nervous system, I decided to break it into two because it's too long, it's too detailed. So last week it was neuron and synapse. So today is the structures and functions, spinal cord particularly, and the brain. So we can begin. Okay, like I've said, Mr. Siyabonga Zwane, you can call me Siya. Basic psychology, PYC1501, human nervous system, structure and function. Okay. You can open your textbook. In my textbook is page 76. Human nervous system, the structure and function. But let's go back a bit. In our last week discussion, human nervous system, we discussed the functions of the neurons, the functions of the neurons, of which it is those who attended the class, particularly those who attended the class. We discussed the main function of the neurons. So before we begin, anyone, what is the function of the neuron? In short, let's reflect back the function of the neuron.
To conduct impulses.
To conduct impulses. Thanks very much. Yes, to conduct impulses or to conduct information or messages. So each and every time we have senses for touch, smell, hearing, visual. As I'm conducting the class right now, you can see the slides. You can see that Jolene is online. What I using is visual. Visual is received by the neuron through the dendrites to transport it to the brain. So the brain will interpret that this is visual. So that's a key function of the neurons, also nerves, to transport information from one place to another. So that's a key. So we can continue. When information is transported from the neurons, the nerves, it needs to pass somewhere. Where does it need to pass? Through the spinal cord and the brain. It doesn't go solo. It needs to be transported from one place to the next. But the most important, the structured particles in our body are neurons and nerves. The nervous system. For you to master nervous system, just ensure that the nervous system are divided into two. We have the central nervous system as well as peripheral nervous system. Central nervous system and peripheral nervous system. When you write your notes, to make things much simpler for you, instead of writing the notes as written in your textbook, make sure that you use this design. We call this design expandable tree structure. It's in your textbook as well or is in your study guide. Yeah, as well as your textbook. Expandable tree structure, whereby you write the main topic as if you're doing brainstorming. You write your main topic on top. The two sides. This is the main body. These are the subtopics. The central nervous system and peripheral nervous system. So what happens in the central nervous system? Central nervous system consists of the brain and the spinal cord. Brain and the spinal cord. As you can see that the brain is connected to the spinal cord. The purpose of the brain and the spinal cord through nervous system is to, which acts as a central control room that sends and receives messages and from the body and the outside. What is the function of the brain and the spinal cord in our central nervous system? Which act as a central control. They act as a central control room that sends and receives messages to and from the body and the outside. What do they mean by this? Like I've said, you receive information externally. Most of the information is coming from the external, whether it's touch, it's smell. As I'm talking to you right now, you can hear my voice, it's auditory. Then that information, you receive that information through the nerves, nerve impulse, the neurons. So it goes straight to the spinal cord. From the spinal cord, you need to be transported to the brain. Then the brain need to interpret what kind of information. Then you react. So the reaction will be outside the body, your behavior. Act as a central control room that sends and receive messages to and from the body and the outside. From the body, not all information comes from the outside externally. It also comes from internally. Internal, what do I mean? For instance, let's say you're hungry now. So your hunger is internally. There are certain hormones that will be stimulated and will send information to the brain via the spinal cord that no, I'm hungry now. I need to go to the loo. Is internally. Information will be stimulated inside and be transported to the brain via the spinal cord. Then the brain will interpret that no, this person needs to go to the toilet. It comes back via the spinal cord to indicate in the organs that I need to go to the toilet. So whether it's hunger or thirst or I'm feeling a pain inside me, I'm experiencing stomach ulcers. How do you know that it's stomach ulcers? Because that pain will be indicated in the brain. Then you know that the pain is in the stomach, is stomach ulcers. Hence they say, which acts as a central control room that sends and receives messages to and from the body. So the spinal cord and the brain plays an important role in receiving. So the brain and spinal cord plays an important role in the receiving end of the information and sending the information. Without the brain and spinal cord, also without the spinal cord, information won't be able to reach the brain. So the spinal cord acts as a relay station for information to be transported. Another example, again, someone touches you. You can feel the touch, meaning the neurons are responsible for that, the nerves. The information is sent via the spinal cord and transported to the brain. If we didn't have a spinal cord, we won't be able to transport information. Okay, for now, let's leave it here. We'll discuss further in our next slide. Then we have the peripheral nervous system. Peripheral nervous system. Okay, the book says the nervous system comprises of two main parts: the central nervous system and the peripheral nervous system. The central nervous system is made up of brain and spinal cord. It can be compared to a central control room that sends and receives information to and from the body and the outside world. The peripheral nervous system is made up of neurons. The peripheral nervous system is made up of neurons as well as organs that lie outside and beyond the brain and the spinal cord as well. It has two main parts, that is somatic nervous system as well as autonomic nervous system. So in short, peripheral nervous system has two main, it functions, it consists of the neurons and the organs. They say the organs which lie outside and beyond the brain, as well as the fact that it's connected to the spinal cord. It has two main parts, that is somatic nervous system and autonomic nervous system. So let's go. I'll skip some information here. Let's go here, then we'll come back. Regarding the central nervous system, the brain and the spinal cord are protected for now. It's central nervous system, peripheral nervous system, brain and spinal cord. That's a key for now. Under peripheral nervous system, the key in neurons and organs. The functions of the brain and spinal cord. The two parts under peripheral nervous system. For now, those are the key. Moving on. Spinal cord. Brain and spinal cord. Spinal cord consists of the spinal nerves and reflexes. The spinal nerves and reflexes. As I mentioned, that the spinal cord function is responsible for transporting information from the inside and outside or from the outside straight to the brain. How does it do that? How does it, because spinal cord is just a bone, but how does it do that? How does it transport information? It transports information through spinal nerves, meaning the spinal nerves are covering the spinal cord. This is the spinal cord, the inside part of the inner part of the spinal cord. Our spinal cord are covered by the nerves all around, the spinal nerves. It's more like the tree, then the stem, the branches covering the spinal cord in order for it to transport information. So it's more like a pole and a wire. It's a pole, a straight pole. In the straight pole, it's covered by the wires. The wires move from up to below. We can say those are spinal nerves. The spinal cord is made up of the column called white matter. So those are the key. During our multiple choice questions, we focus on the key aspects. The spinal cord is made up of the columns of white matter. Columns of white matter, that is branches of axons covered with myelin. So this is the spinal cord. Around the spinal cord, there are spinal nerves. The spinal cord is covered with white matter. So keep in mind, white matter. That is branches of axons covered with myelin. Remember axons and neurons, almost the same. You just use the words interchangeably. So when I say to axons, I say neurons. Think of axons as well as nerves, because they play the same role, that is to transport information from one place to another. That is the bundles of axons covered with myelin. Remember, myelin sheet. Myelin sheet is a fatty sheet that covers the axons for it to transport information much quicker. It's a cover, it protects the axons and it facilitates information to be transported much quicker. That's the purpose of myelin. We discussed it last week. They form nerves. So these axons, they form nerves. 30 pairs of nerves surrounding the spinal cord. There are 30 pairs of nerves surrounding the spinal cord. A spinal cord, imagine a pole, a straight pole with wires. It's covered by 30 pairs of nerves that transport information. And each of those nerves divides into a motor and sensory root. Motor and sensory root. Let's start afresh. The spinal cord. Spinal cord, just imagine a pole with wires that transport electricity. However, with regard to spinal cord is covered by several nerves. They say 30 pairs of nerves. The spinal cord is spinal nerves. The spinal cord is made up of columns of white matter, that is bundles of axons covered with myelin. It's covered with myelin so that the information can move much quicker. These axons, they form nerves. We can say spinal nerves. They form nerves, 30 pairs of nerves surrounding the spinal cord, each divided into two, motor and sensory roots. Why motor and sensory roots? So motor and sensory roots, they play different functions. There's one form of a nerve, a spinal nerve, a sensory root that receives information. There's one receives information. One the in and out. This is the in, receives information, takes out the information. Receive the information, takes out the information. So it's sensory roots and motor roots. I said to use see figure point 1. This is figure point 1. Let's try to understand the structure. 1. Sensory fibers carries messages to the spinal cord. When you receive information, as I'm talking to you right now, auditory, and you can see the slides, of which is visually, sensory fiber are responsible to carry the message to the spinal cord. You receive information through the nerves, particularly sensory roots. Sensory roots receive that information. What does it take the information? It takes the information straight to the spinal cord. As they mentioned here, it takes the information straight to the spinal cord. Two, we have motor fiber. That is a motor. A motor fiber sends a message to the muscle to respond. To see the difference. When you receive information through the neurons, nerve impulse, it takes the information to the spinal cord. The process of taking the information to spinal cord is sensory fiber. Then the information needs to be taken out, need to respond. Then the function is motor fiber sends message to the muscles to respond. I touch you right now, you receive the information through nerve fiber. Then your response is, who's touching me? Who's touching me? That is motor fiber. That's a responsibility. Who's touching me? Your reaction to the touch. Motor fiber sends information to the muscle to respond. I hope it makes sense. Then we have the interneuron in the spinal cord relay the message to the motor fiber. So in short, the message is from sensory fiber when you receive it and go to the spinal cord. It doesn't go straight to, it's not yet converted to motor fiber until it passes what we call a relay station. Interneuron of the spinal cord is relay the message to the motor fiber. So sensory information comes in, you receive the information, it goes straight to this part, interneuron in the spinal cord, relay the message to the motor fiber, then go to the motor fiber. So that's the difference between the two. These are the neurons or the nerves that are responsible to transport information from the in and out through what you call the spinal cord. So this information happens quickly. You can't see it, you can't even feel it. Hence they say reflexes. Reflexes means is speed. It's quick reaction. The spinal cord carries information to and from the body by producing basic forms of behavior called reflexes. The spinal cord carries information to and from the body by producing basic forms of behavior called reflexes. A reflex is a simple stereotype response that follows immediately after a certain stimulus is received. Remember stimulus. A stimulus is any information that you receive. Whether it's touch, what you see, what you're hearing, it's a stimulus. It's called a stimulus. Anything that you receive that triggers your behavior is stimulus. So before we continue, let me check if what I've just discussed makes sense. Okay, before I move to the next slide. The central nervous system, the brain and the spinal cord, the key structures of the brain and the spinal cord. Let's start with the brain. The brain is protected by bones called skull. What protects the brain? The brain is protected by bones called skull. You are familiar with the concept skull. So it protects the brain. Here you can see the spinal cord. Then the spinal cord is protected by bones of the spinal column. Bones of the spinal column called vertebrae. And the three membranes. Brain is skull, spinal cord, vertebrae. So those questions might come. What protects the brain, what protects the spinal cord? They're both protected by bones, but the brain is protected by what is called the skull. The spinal cord is protected by what is called vertebrae. So the vertebrae are also divided by three membranes. That is the outer membrane called dura mater, which is very thick and strong. That is an outside. Put this into mind. as you can see, the brain, the spinal cord is more like a spring. It's more like a spring. It needs to bend. It allows you to stand. Beside the fact that it is covered by nerve to transport information. However, it also allows you to bend, to have balance. When you fall, when you trip, the spinal cord is responsible to maintain your balance. So what happens here? The bones within this, you can see these are the patterns. Bone 1, bone 2. In between, you see the gaps, the spaces here. That's where you'll find the membranes which protect the spinal cord, so that the bones won't clash. For the bones not to clash, the membranes are responsible to make sure that there's a smooth interconnections of the vertebrae. Same applies to our body. Elbow, the connection between a hand and an arm. There are cartilages, yes, but you also find the membrane, the joints, the cartilage that are responsible, that ensures that your body, your bones does not meet, because once the bones meet, there will be irritation. Chances are will even be paralyzed. Same applies to the spinal cord. It's connected by the membranes in between for a swift movement. 3 membranes. The outer membrane is the dura mater, which is very thick and strong, because it's an outside one, is very thick and strong. The middle membrane, which is arachnoid, which is thick but more flexible. It's thick but more flexible. Then the inner membrane, which is soft and flexible, so the inner one, which is soft and flexible, we can assume that is where the nerves, that's where you can find most of the nerves, because nerves are sensitive. They need to be in a soft and flexible place. So this structure, the small structure here, you see the pi mater, which is the inner, the blue one. The pi mater, which is soft and flexible. Then arachnoid, which is the middle one, that is thick but more flexible, and dura mater, which is the outer one, which is very strong and thick. So these are the key that protects the brain and the spinal cord. The brain is just short, protected by skull. Spinal cord, vertebrae. Vertebrae has 3 membranes. That is dura mater, which is outside. In the middle, arachnoid. Inside is pi mater. So that's it with regarding to the protection of the brain and the spinal cord. Also, when you study, firstly, you study the whole chapter. Then you design your own notes. Yes, the book will give you the guidelines on how to do your notes. The study guide will give you a guideline on how to study. However, you divide it in a way that's suitable for you. As you can see here, I use the expandable tree structure. The main body in nervous system. The 2 subtopic, central nervous system and peripheral nervous system. You check, what does the central nervous system consist of? What are the key? What does it consist of? It consists of the brain and the spinal cord. What's the purpose of the spinal cord? This is the purpose of the spinal cord. You leave it there. So that's a key. Secondly, peripheral nervous system. Why peripheral nervous system? It consists of the neurons and the organs. The peripheral nervous system is also divided into 2 main parts. That is somatic and automatic nervous system. Those are the 2. You stop there. Further, what is a brain? Brain and spinal cord. You move to the next part. The spinal cord. You discuss the spinal cord on its own, because it has its own main function. Move on. So what protects the brain and the spinal cord? You discuss it, you write your own notes what protects the brain and the spinal cord. Then you have to move to the major structures, because when you ask you questions, in human nervous system, you have 50 multiple choice questions. I'm not sure whether the examiners or the lecturers might change, because most have changed it from 50 questions to 70. I'm not sure what this one should be for now. They changed because we have one semester now. If it's 50, let's assume 50 questions per exam. Human nervous system, normally you'll find 10 to 12 questions, mainly under human nervous system, because it's the most detailed chapter. You'll find 10, 12, or 15 times. When you ask you questions, so make sure that you ask you questions regarding the brain, because as a psychology student, social work student, or any human behaviorist, you want to specialize in as a human behaviorist, you need to know about the brain. That's a key. You need to know the functions of the spinal cord. When you ask you questions, ask you questions wanting to make sure that you carry this information to your second level, third level, your honors level, master's, even doctorate, until you become a specialist. You need to know the functions of the brain. Major structures of the brain. Major structures of the brain, we have forebrain, midbrain, and hindbrain. So those are key. Forebrain, midbrain, as well as hindbrain. Let's start with forebrain. Where is this? You can open page 81. Figure 3. Open figure 3 in your textbook to see the structure of the brain. So forebrain consists of 4 structures. That is thalamus, hypothalamus, basal ganglia, as well as limbic system. You can also hear the corpus callosum. That's a forebrain. What are the functions of the thalamus? Now that you know the structures of the brain, you need to know what is the function, number 1, of the thalamus. So all this information, I've taken it from your textbook, your study guides. It's just that here I've given you a summary. Thalamus acts as a relay station for sensory information. It's one important structure of the brain, acts as a relay station for sensory information. A relay station, what do they mean? When you receive information, it's taken from the outside via the nerves. It goes to the brain, from brain to the spinal cord. From this information via the nerve system, the neurons, it goes straight to the spinal cord. From spinal cord, it goes straight to the brain. When it reaches the brain, it goes straight to the thalamus. The thalamus acts as a relay station for sensory information. That's where the information is interpreted first. The structure of the brain where information is interpreted. So hope you understand. Then 2, we have the hypothalamus. Hypothalamus regulating the internal environment of the body. Regulate the internal environment of the body, which is the state of sleep, wakefulness, and emotions. That's the responsibility of the thalamus. Regulate the internal environment of the body, the internal, inner. Regulate your sleep, wakefulness. So your sleep, wakefulness, and emotions are regulated by what the structure called hypothalamus. Then we have basal ganglia. Basal ganglia consists of neurons that regulate walking, whether walking slow or faster. The structure that is responsible is basal ganglia. We also have the limbic system. Limbic system comprises of structures like hippocampus, amalgama, sectum, limbic cortex that regulate motivated behavior, emotions, and memory. So all these structures under limbic system, that is hippocampus, amalgama, Septum limbic cortex regulates motivated behavior, emotions, and memory. So those are the key structures. Then there's one structure that I didn't mention, corpus callosum. When you check figure 3, you'll see corpus callosum. But we'll discuss corpus callosum when we discuss the hemispheres, corpus callosum. Then the midbrain. Midbrain, we have septum and segmentum. Septum contains two structures, that is superior colliculus as well as inferior colliculus. Superior colliculus is a reflex center for controlling an eye blink the size of a pupil. It's a reflex center for controlling an eye blink and the size of the pupil. So septum is to do with the eye. It's situated in the visual space, the eye. It contains two structures. Structure number 1, superior colliculus, the sense, a reflex center for controlling an eye blink and the size of a pupil. Inferior colliculus, a reflex center for hearing by controlling volume. Thirdly, a response to sound. That is septum. Then segmentum is regulation of motor movement. Regulation of what? Motor movement. Motor movement is motor movement. The way you move your body, the way you move your hands, your gestures, your postures are regulated by motor movement. When someone touches you, your reaction, when you experience any form of motor coordination, is regulated by septum. I touch something and I feel the heat, I move my hand very quick, much quicker. That is motor movement. I play tennis, I play soccer. Those are motor movement. Then hindbrain. Hindbrain consists of 3 important structures, that is pons, cerebellum, as well as medulla oblongata. Medulla oblongata is a reflex center for processes of survival, such as heart rate and breathing rate. So medulla oblongata is the most key structure in our body, in our brain. It's the most important structure. If your medulla oblongata is affected, like as they say, it's a process of survival, heart rate and breathing rate. If your medulla oblongata is affected, then that equals to death. You die instantly. Or if they hit at your medulla oblongata, there's so many chances that you can collapse instantly. When you watch in the movies, most of the time in the movies, you can see they normally hit one another at the back of the neck and someone might collapse instant. So they're trying to show that the importance of medulla oblongata. Whether they hit you with the back of the gun, then instantly you fall down. Whether with a bottle or at times with a fist. Depends how intense the hit is. So once they hit you at the medulla oblongata, meaning your heart rate, your breathing rate is affected. Survival, you die instantly. That is why, as well as in certain countries, Asian countries, Belgium, where they still have death penalties, how they apply it, how they assassinate you, you kneel down, they point the gun at the back of straight to the medulla oblongata so that you won't feel any pain. Then they pull the trigger. Africans, when we kill the cow, what do we insert the knife? Medulla oblongata on top of the head. We'll see the cattle, the cow medulla oblongata is on top of the head where they insert the knife. It's medulla oblongata so that it can die instantly without feeling any pain. That is medulla. The most important is the survival. In multiple choice questions, we must say which structure of the brain that is for survival purposes: heart rate, breathing rate. That is medulla oblongata. Then you have pons. Pons regulate sleep and wakefulness. Sleep and wakefulness. When you study this part of the brains, you need to also look at the similarities. The similarities that the structures facilitate. Some functions are similar. As you can see here, pons regulate the sleep and wakefulness. What are the structure of the brain that regulates sleep and wakefulness? Hypothalamus. It's a state of sleep and wakefulness. The state of sleep and wakefulness. They contain similar functions. So that's where students get confused when they ask questions. So you need to know that under forebrain, the structure that is responsible for wakefulness and sleepiness is hypothalamus under forebrain. Instead, under hindbrain, that is pons, which regulates sleep and wakefulness. So when they ask questions, ensure that you will see, will indicate whether that part of the brain is under is hindbrain or forebrain. So that's the key. Under hindbrain, we have cerebellum. Cerebellum again, coordinate motor movement. Coordinate motor movement. Segmentum, regulate motor movement. The key as well, the way we phrase it in the textbook. Here we say it regulates motor movement. Here, coordinates motor movement. It regulates sleep and wakefulness. Here is a state of sleep and wakefulness. You look at the keywords. If the question confuses you, when you study, ensure that you know the keywords. Regulates sleep and wakefulness. Here is the state of regulates the states of sleep and wakefulness. It regulates motor movement. Coordinates motor movement. But most particularly, make sure that you know the structures under the midbrain. Mention under hindbrain, there's a structure that regulates motor movement. Under midbrain, there's a structure that regulates motor movement. Then you know under hindbrain, you only have sectum and segmentum, not cerebellum. Cerebellum is under hindbrain. That's how you master it. Then you give you options. Is it septum, segmentum, cerebellum, or pons? Then you choose options, 4 options. So no, under midbrain, definitely you only have sectum and segmentum. And that's it. So moving on. So this is a summary of the brain as it is, as detailed as it is. The brain. The brain consists of the cerebral cortex. Cerebral cortex is an outer layer of the brain with features. Cerebral cortex is an outer layer of the brain with features, with bumps and grooves. The cerebral cortex is an outer layer of the brain with features, with bumps and grooves. What do you mean by bumps and grooves? Let's go back. Do you see your brain? It contains bumps and features. These are the tracks. Bumps and grooves. They are describing the brain, the structure of the brain. Bumps and grooves. The cerebral cortex is the outer part of the brain. Cerebral hemisphere connected by the structure called corpus callosum. cerebral hemispheres. The brain is divided into two. That is left hemisphere and right hemisphere, through what is called the cerebral hemisphere. So this is your brain. Your brain has two parts, left part and the right part. Cerebral cortex, cerebral hemisphere. The left side is left hemisphere, the right side is the right hemisphere. What is the purpose of the left hemisphere? The left hemisphere is for logic and rational thinking. Right hemisphere is for creativity. So let me give you an example here. Let's use mathematics engineering students mostly. In university, we have bachelors of arts, we have bachelors of commerce, engineering, those who are doing agriculture. So according to this information, they say left hemisphere it requires mostly logic and rational thinking. As a mathematician, somebody who's studying maths under the College of Engineering Science, mostly they are using their left hemisphere because they need to do formulas from step 1 to step 2. They do formulas most, so that is through the hemispheres. When they say to you solve for x, you need to start from step 1, step 2, step 3. So you do that through the hemispheres. You do that through the left hemisphere because it's responsible for your reasoning, logical, rational thinking. There's no creativity mostly, but logic. Again, psychological students, they are logical thinkers because you need to apply when you in a session, when you do counseling, when you get in the workplace, you need to apply logic, reasoning. You need to apply the theories that you've studied. You cannot use creativity when you're studying a brain. You can use creativity when you're doing your notes, but when you're working with a person, when physicians perhaps they're operating the brain, they're using their logic, rational thinking, because this is a sensitive organ, no creativity. So left hemisphere mostly is art. Art is more like creativity. Art, musician, dealing with the structures, artists, they are using their right hemisphere. It's for creativity. So they are not saying, please note, they are not saying engineering students mostly, not mostly, mainly use their left hemisphere. They are not saying that. However, most of their studies, most of their application, they use the left hemisphere. Not only they use left hemisphere. They mostly use it when they are studying, applying their theories. However, they can use both hemispheres, the right and the left. So all of us use both hemispheres, depending on what you do in that particular moment. For protection purposes, the space between the skull and the brain is filled with a fluid called cerebrospinal fluid. For protection purposes, the space within the skull and the brain, this is the skull and this is the brain. They are not connected. They are not supposed to clash. As you can see, this is a pons in the spinal cord. They're carrying a brain, so that again it won't touch the spinal cord. So what they're saying here, there's a fluid surrounding the brain and the spinal cord to avoid sensitivity, to make sure that the brain and the skull don't clash. That fluid is called cerebrospinal fluid, produced is produced by the brain and also protected by the blood-brain barriers and blood vessels called capillaries. Let's start afresh. For protection purposes, the space between the skull, the space between the skull and the brain is filled with a fluid. That fluid is called cerebrospinal fluid, produced by the brain, also protected by the blood-brain barriers as well as blood vessels. Blood vessels called capillaries, which are permeable to many substances. As much as they protect the brain, they are impermeable to many substances. Remember last week I said to you, the neurons are covered by membranes. The membranes are permeable to certain substances, fluid mostly, and the chemicals. They are permeable. What do you mean by permeable? Permeable, these capillaries are more like a sponge. As much as they protect the brain, they allow certain substances to go in. It's more like a sponge. A cotton, a filter. Yeah, they act like a filter. They allow certain substances to go in, certain substances to go out, and they don't allow certain harmful substances to affect the brain. Capillaries, which are permeable to many substances, that carries important substance. So they allow transportation of many substances that carry important substance. So they allow oxygen, glucose to the brain, and transport out waste products. They allow oxygen and glucose to go in, move in and out. So that's the purpose of the capillaries. They are permeable to important substances. What are those important substances? For the brain is oxygen and glucose. They also allow the waste product to go out. That is why when you take drugs, when you take substances like drugs, alcohol, in the later stage, or when you take too much, they affect your brain, they affect your capillaries because they are too toxic for your capillaries. They don't need to be there. But when you drink too much, when you take too much of those substances, automatically they'll affect the capillaries. Your capillaries, in the end, won't be permeable. It will be impermeable to all the substances. Remember, brain only needs oxygen and glucose for it to function. However, due to toxic substances that people normally take, then the capillaries won't be forever impermeable to these substances, because these harmful substances affect the capillaries so that they can take anything inside and out. So that is the key. Okay, let me read this. Let me check if I skipped any important points. Okay, let me read it for you in your textbook. Under the brain, 1.2, the brain. They say the brain is an extreme complex organ. It is estimated that there are 10 billion neurons in the brain, and that any one of them may have 1,000 connections with other neurons in the brain. Like I've said, your body consists of billions of neurons, interconnected. The neurons are more like a chain. They're connected to one another. The space between the skull and the brain, yeah, as I mentioned, that is filled with cerebrospinal fluid, which is produced by the brain and surrounds it. Basically, the brain floats within the skull. It floats within the skull through these fluids. The brain is protected from being bumped about and injured. Again, this fluid ensures that the brain does not bump the skull. It's protecting for any injury. When you fall down, it makes sure that your brain doesn't hit the skull. The brain is also protected by blood barriers blood-brain barriers that keeps out certain harmful substances. The brain is rich with is a rich supply of blood vessels that carry important substances like oxygen and glucose. I'm getting somewhere. They say in the brain, the passage of drugs is much more difficult than elsewhere in the body because of the tiny blood vessels. They say in the brain, the passage of the drugs is much more difficult. Drugs, whether it's substances like alcohol or drugs, they're difficult to pass than because the body in the brain, the passage of the drugs is much more difficult than elsewhere in the body because of the tiny blood vessels. So the blood vessels are so tiny. Yes, they only allow oxygen and glucose. They're tiny. Not any substance can pass through. However, only glucose and oxygen will be allowed to pass through. Like I've said, however, too much of these substances will affect those neurons, will affect those blood vessels. And that's what I wanted to emphasize. The importance of these blood vessels. They are tiny in a way that they only allow oxygen and glucose, but the only threat is the substances, the drugs. The only threat to these blood vessels and blood barriers is the drugs. That's what they're trying to elaborate to us. Moving on, the brain consists of the lobes, 4 lobes: occipital lobe, parietal lobe, the temporal lobes, and frontal lobe. 4 of them. Occipital lobe, which regulates vision, a visual area. The occipital, they say occipital lobe lie at the back of the brain and are primary visual areas. Examples of this are the ability to perceive that eyes and nose and mouth make up a recognizable face, or that group of letters make a word. So your ability to see, your ability to, let's say you are standing outside, you are waiting for Sezwani. From far away, you can see that no, that is Sezwani. How come you can see? How can you conclude that this is Sezwani? No, I know his car. His car is red, perhaps, meaning you have used your occipital lobe. In short, occipital lobe, not only you can see the visuals, but you can determine the color. You can interpret the color. You can interpret the movement of a person, the size of the person, the fact that you can identify that I have a scar on my face, meaning that you are using your visual. Then you have peripheral lobe. Peripheral lobe, body senses, regulate your body senses. Body senses of which is sensation such as touch, temperature, pressure, and pain. Your ability to use your body senses, touch, temperature, pain, and pressure. That is peripheral lobe. Temporal lobe. Temporal lobe regulates the auditory area, determines your hearing, also determines the volume, how loud the sound is, how soft the sound is, what type of the sound. And like, as for instance, right now, while I'm presenting the class, I can hear the wind is blowing. It's because of the auditory, meaning you can differentiate between the different sounds, auditory area. Then the frontal area. The frontal area functions is so. The frontal lobe represents the most recent involvement part of the brain. They regulate complex mental activities and behaviors. Motor movement. So frontal lobe has many functions. Motor movements you'll find under regulation of speech, voluntary movement, the thinking, the reasoning, planning. So frontal lobe has many functions. You can study them further. But make sure that you know the difference between this lobe. What does this lobe represent? Okay, moving on. Peripheral nervous system. So we are done with the central nervous system. We're moving to peripheral nervous system. As I mentioned in the beginning, peripheral nervous system, we said neurons and organs, somatic and autonomic nervous system. So the detailed information regarding peripheral nervous system. Somatic nervous system, what's your understanding of somatic nervous system? It refers to the nerves that conduct information from the sensory receptors in the body to the central nervous system. Somatic refers to the nerves that conduct information from sensory receptors. Remember, sensory receptors, the one that receives messages in the body to the central nervous system. Whether sensory, we can say sensory or afferent. Afferent and sensory is almost the same thing. From the central nervous system to the skeletal muscle. Let me read it short. Somatic nervous system refers to the nerves that conduct information from sensory receptors in the body to the central nervous system, and from the central nervous system to the skeletal muscles in the body. So that is mostly is reaction. You receive information internally. Somatic is internally. An indication that I'm hungry now, or I need to go to the loo, or I have a pain somewhere. The nerve will conduct that information from sensory receptors in the body internally. Then from the central nervous system, when I say central nervous system, remember it's brain and spinal cord. Brain and spinal cord. Central nervous system conduct information from sensory receptors in the body to the spinal cord and the brain, from the brain and spinal cord to the skeletal muscles. Your reaction in the body, that is motor or afferent. So when the information goes straight to the muscles so that they can respond, that is motor or efferent nerves. Then you have the autonomic nervous system. Autonomic nervous system controls the process that regulates our internal organs, glands, so that the body functions evenly through sympathetic and parasympathetic. Autonomic nervous system controls the process that regulates our internal organs and glands. For instance, when you see danger, or when something stimulates you, when you see a danger, what happens to your body? Your heart rate will be high. Your blood vessels will be high. Please close your mic. Close the mic. When you see danger, automatically your organs like your heart pumps. Internal organ, certain glands are stimulated, certain hormones are released, depending on what stimulates you. Yes, they say under autonomic nervous system controls the process that regulates our internal organs, mostly your heart, your lungs pumps high when you see a danger. Certain glands are stimulated so that the body functions evenly through what is called sympathetic nervous system and parasympathetic nervous system. What's the difference between the two? The effects of stimulation of the sympathetic and parasympathetic nervous system. Sympathetic nervous system, when you see danger, let's say when you see a snake, pupils of your eye dilate to let more light. Like when you are shocked, when you're shocked, you can see your eyes. They become wide open. So the pupils of your eye are dilated and to receive more light because you are shocked. Like that WhatsApp emoji where you are shocked, you open your eyes wider. Structures of the lung expand to absorb more oxygen. Structures of your lungs expand to absorb more oxygen. The heart pumps blood. The heart pumps faster and blood pressure rises. Your heart pumps faster and blood pressure rises because you're in a shock, in a disbelief, or you're too excited. At times when you're too excited, more blood reaches the muscles to increase the supply of oxygen and glucose. More blood reaches the muscles, so immediately your more blood reaches the muscles to increase the supply of oxygen and glucose. Less blood is available to the skin and digestive organs, so that more is available for the brain and the skeletal muscles. For example, in this case, they say less blood is available to the skin and digestive organs, so that more blood will be available for the brain and skeletal muscles. When you are shocked by something, or when you are in a danger or accident, so automatically to avoid the brain from hitting the skull, automatically, these things are reflective, they are so quick. Automatically, enough blood vessels, enough oxygen will go straight to your brain to avoid it not being affected. Like they said, less blood is available to the skin and digestive organs, so that more is available for the brain and the skeletal muscles. So that is to protect the important structures of your brain, of your body, the brain and the skeletal muscle. Stroke. When you experience stroke, meaning there's a shortage of blood in certain parts of your body through the blood vessels. And when you are shocked or in a car accident, to avoid that again, the blood needs to move straight to the muscles to allow that flexibility, to avoid that dryness. Like you not to be affected by stroke, you not to be affected by heart problems, cardiovascular disease. So the blood moves to the certain important parts of the body to avoid that sudden collapse. That is sympathetic nervous system. So the sympathetic nervous system is a reaction when you see a danger. Then parasympathetic nervous system is an opposite. Yenze paralyzed. The sympathetic stimulates, para inhibits. Parasympathetic nervous system, it's an opposite. People contract to limit the amount of light. Here more light comes in. Here people contract to limit the amount of light that enters the eye, or optic muscle adjust. There is a decrease in lung action. Here there's an expand in lung action. There is a reduction in blood pressure and heart rate. There's a reduction. Here it's fast, it rises. Some muscle relaxes, whereas here more blood reaches the muscles. Muscle relax. Blood supply to the skin is restored. The blood supply to the skin is restored. So here, sympathetic nervous system, you're seeing a danger or you're too excited. Then later in the stage, you have more sense of it, you come down. This is para. Whereby you come down, everything gets back to normal. It's there. It's everything gets back to normal. Okay, so that's the end of the first part of our lesson. I will repeat the important factors, but before I do that, any questions with regard to what I've discussed? Any elaborations?
I would just quickly like to find out from you the waste that the capillaries are transporting outside of the body. Would that be the neurotransmitters that has not been used?
Yes, neurotransmitters that are not being used, as well as for any you receive oxygen, then you take out carbon dioxide. So that is another substance. When oxygen comes in, is converted to carbon dioxide. So it's chemicals that are not being used, as well as carbon dioxide.
Okay, great stuff. Then the other thing, can you just go back to the lobes?
Okay, here are the lobes.
Thank you so much. So what I did was, you see the O. I used
The
the
O.
O. Yes, I used the O to make an I so that I can remember its visual.
Okay.
The
O.
P, the P I used for pressure and pain.
Okay.
The T, or the word tempo in temporal lobes, you hear tempo when you listen to music.
Auditory. Okay.
And the F, R, I use for friendly, which would be behavior.
Okay, that's good. Can you please repeat that?
Okay, so the F, I used I use the word friendly to remember so that I can remember it's the frontal lobe, and it's friendly, and that would be behavior. The tempo in temporal lobe, I use it's music, so I can hear music. That's for ears. The P in parietal, I use pressure and pain so that I can remember its sensation. And the O in occipital, I use the O to make an I, and that will be visual.
Okay, thanks very much.
It's just a tip.
I will adapt that in my next sessions next year. Thanks very much.
Okay.
Thanks very much. So let me repeat it for students so that we can be clear. Jolene is saying occipital, because of this O, you draw this O and you design an I because it's visual. You draw an O, you design an I because it's visual, what you can see. P body senses, and two key body senses that are regulated by peripheral is pain and pressure. So P stands for pain and pressure. Parietal lobe, those are the key. Then temporal, since it's auditory, that is hearing. Tempo, when you open the music, when you increase the volume, you can feel the tempo. Tempo is to do with auditory, hearing. Then frontal lobe. Frontal lobe, I forgot. Jolene, you said F is for?
Friendly.
Friendly. Okay. You associate, okay, frontal and friendly.
Yes,
okay.
Yes, friendly as a behavior.
Behavior. Oh, yes. Frontal lobe coordinates most of the behavioral patterns. As a behavior. Besides behavior, then you have emotions. So frontal lobe consists of several functions of the body. Oh, thanks very much. That's clear.
I see. Sorry, it's got nothing to do with today's session. Kindly explain to the student. One student sent us an email regarding the assignments. She's asking about assignment 3 and 4. I know normally it's for evaluation purposes, not for submission to. No, it's for self-study, not for evaluation purposes. Kindly clarify that with them, please.
Okay. So regarding assignment 3 and 4, I'll give you two explanations. Recently, the assignment department, as well as the lectures, they discovered that some of the students have submitted wrong assignments, incorrect assignment. Remember, in the beginning, we sent you tutorial letters, tutorial letter 101 for both semester 1 and semester 2. However, due to COVID, the strike, the semester were combined into one. Now we have only one semester, meaning you are writing October, November. Due to that, the lectures introduced new assignments for students to do. They introduced new assignment. We were supposed to do one assignment, whether you have registered first semester or second semester. We are required to do one assignment under tutorial letter 001. However, some students continued continue mainly focus only on tutorial letter 101 and they submitted incorrect assignments. Then the assignments and the lecture decided no, man. Due to that challenge, since the students have submitted the wrong assignments and some received 0, what we can do now is introducing assignment 3 and 4. For those who have submitted wrong assignments and for those who were not able to submit the assignments, basically to make sure that you fix your marks. Because you couldn't submit assignment 1, perhaps you have an opportunity to submit assignment 3 and 4. But this is a recent information. You'll see in your assignment portal, they might introduce, you have submitted assignment 1 and 2, below in your assignment submission, assignment portal, they might introduce assignment 1 as well as they might introduce assignment 3 and assignment 4. But it depends. You make sure that you look at your announcement. Then tutorial letter, we have additional assignments. And particularly under assignment 1, we have additional assignment 2 assignments. That is for self-assessment, like Mr. Keller is saying. We have 2 additional assignments for self-assessment. They are written for self-evaluation. You don't need to submit them. It's for you to prepare for exams. So check your announcements much clear. If there's under your assignment submission, if there's assignment 3 and 4 that is open for you to submit, double check first before you submit. Look at tutorial letter 101. Look at your announcement. I hope I'm clear.
So is it additional tutorial letters here? Is it on additional tutorial letter, on additional resources?
They haven't yet loaded anything.
Oh, okay.
They just said we'll introduce assignments for those who are affected by the strikes and COVID, the delay. So they haven't yet introduced any assignment. They just opened the portals, portal 3 and portal 4.
Okay. I
Yes.
see there's a hand.
Yes, I can see the name. Who is she? Okay, you can ask the question.
Okay, morning, Sia.
Morning.
2 things, ne? First thing in regards to assignments. For example, let's say you're happy with the results of assignment 1, but not 2. Can you submit assignment 4 only, not 3? Then in terms of the content, can you kindly go back to reflexes? I'm just a bit confused there.
Okay. With regard to the assignments again, what I will do, I will speak to your main lecturer, Mr. Kosana, and double check. I'll make sure that I'll come with the concrete information next week. Currently, they haven't introduced those key assignments. They've discussed it, send the emails, but they haven't discussed what type of assignments are those. So answering to your question, there's no clear information for now. I will speak to Mr. Kosan and next week when we meet, then I'll give you the details.
Okay.
Yes. Okay, reflexes. Okay, before we have 30 minutes. Before we close the session, I will repeat all the slides, particularly the reflexes.
See, they're asking about the exam dates. When are they writing exams?
Oh, there was an announcement early this year that the exam will take place between September and November, meaning you'll get your timetable either next week or earlier September. It's not official yet. They haven't released any timetable.
Sia, maybe we will be able to assist. We'll also check if the dates are available at the examination department. We'll verify that, and next week, if there are any new developments or any dates available, we will provide the students with the dates on the session next week.
Good morning, sir, and morning, ma'am. How are you?
Okay, thank you.
Okay, I just wanted to say, should disregard the dates that we seen on the timetable that's at my life right now, because it's saying June and July for the exams.
Yes.
All right. Thank you.
So I'll give you just a summary. Okay, number one, as I've said, for those who came in late, the central nervous system. The central nervous system, the human nervous system are divided into two units. That is neurons as well as the structures of the brain. It's nerve impulse as well as the structures of the brain. So today we are dealing with the brain and structure. Number one key, we have central nervous system and peripheral nervous system. Central nervous system consists of the brain and the spinal cord, whereas peripheral nervous system consists of the neurons as well as the organs. What's the function of the brain and spinal cord? They act as a central room that sends and receives messages to and from the body and outside the world. So the key functions of the brain and spinal cord is to transport information, whether from you receive information from the outside through the dendrite neurons, they go to the spinal cord to the brain. So without the brain and spinal cord, we won't be able to circulate the information. Hence, I've designed this information circulating from outside to the spinal cord. Spinal cord, for it to be interpreted, it goes to the brain. Brain interprets the information, comes back to the spinal cord. Spinal cord is sends back to the masses so that it can respond, reflect. Peripheral nervous system, neurons and organs. Organs they are referring to when you see a danger or when something is sight to, the organs react. What are those organs particularly? Lungs, heart rate. The heart is as an organ. They react. Once they react, that's where the blood vessels move in. Then you have sympathetic and autonomic. Please close your mic. Close the mic. Somatic nervous system, autonomic nervous system, and the peripheral nervous system. Moving on, the spinal cord. Spinal cord, like I've said, is more like a pole, a street pole. A street pole is covered by the wires. So spinal cord is covered by the axons, the nerves, called spinal nerves. It's covered by those wires called spinal nerves. Spinal cord is made up of a columns of white matter. So they are white matter. That is bundles of axons covered with myelin. So the bundles of axons are covered with myelin to determine the speed, to make sure that the information moves quickly through reflexes. The information moves quickly through reflexes. They form nerves, 30 pair of nerves surrounding the spinal cord, and each nerve divides into a motor and sensory. So these nerves are divided into two. There's the one that receives information so that it can be sent to the spinal cord, and the one that receives information from the spinal cord back to the muscles. These are the two. Sensory fiber carry message to the spinal cord. From outside to the spinal cord, it needs to be interpreted. Interneurons in the spinal cord relay the message to the motor fiber. Interneurons in the spinal cord relay the information to the motor fiber. That is what happens. That's where it takes place. Relay the information to the motor fiber. Motor fiber sends the message to the muscles. So motor fiber allows that to respond. Sensory receive the information. We receive that information through sensory. So it's an intake. Intake is sensory. Motor, that's where you behave. And it went to the spinal cord. It allowed the masses to respond. Then reflexes. The student asked me to repeat reflexes. Reflexes number one. Let's start here. Reflexes, when you say something is reflexive, it means it's so quick you can't even see it. Like I've said, when you touch a hot plate, a hot stove, or when you touch boiling water, you can't even touch boiling water because they are boiling. Your reflex will be much quicker. When something hits you, you respond quickly. That quickness is called reflexes. We move by reflexes. As I'm talking to you right now, you receive information. It goes straight into your dendrite, neurons, your brain. You can't feel the movement because it's so quick. They say it's less than per second. It's reflexes. They determine the quickness of it. The spinal cord carry information to and from the body by producing basic forms of behavior called reflexes. So the forms of behavior called reflexes, the quickness of that movement, of which we cannot feel the movement because it's so swift, it's so quick. A reflex is a simple stereotype response that follows immediately after a certain stimulus. You have received a certain stimulus. An electric shock, when you experience an electric shock, like it moves quick straight to your brain in seconds. Straight, you leave that plug. You touch the plug, then there's an electric shock, you leave it automatically. Because you have learned that this is electricity, you have learned that you cannot touch acid, you cannot touch boiling water. You learn through the process. So our movement will become reflexive. You don't need someone to tell you, no, those hot water, you will get burned. As soon as you touch, you remove your hands. So that action is reflexive. What else? Another example will be when you're drinking tea, your hot tea, you don't drink, you sip. Why do you sip? To avoid being burned. So that movement again is reflexive. You just sip and swallow quick. Sip and swallow quick. That is reflexive. It's a stereotype response. A reflex is a simple stereotype response that follows immediately after a certain stimulus has taken place. When you switch off, when you light your cigarettes, you inhale, you make sure that you throw that stick away. So the movement is reflexive. You don't need to get burned in order to see that this is burning. I hope I've answered the students. Okay, brain and spinal cord. The key, what protects the brain and the spinal cord? The brain is protected by the skull, whereas the spinal cord is protected by the bone called vertebrae. The vertebrae are divided by 3 membranes. That is dura mater, which is thick and strong. Arachnoid, which is in the middle, thick and more flexible. The inner membrane, that is pi mater, which is soft and flexible. So those are the key major structures of the brain. When you study this, make sure that you check the similarities between the functions. Thalamus, of which forebrain. The brain is divided into 3: forebrain, midbrain, and hindbrain. Thalamus acts as a relay station. When you receive information from the spinal cord and is taken to the brain, the first contact of information is the thalamus, acts as a relay station for sensory information. You receive information, goes to the thalamus, then the thalamus decides that no, this is for motor movement. It takes it straight to the important structures. This is for pain. It takes straight to important structures that detects pain. And this is for memory. It takes the information straight there. Hypothalamus regulates the internal movement of the body. So that is the key. The internal movement of the body, not the external. So you can highlight here the internal movement of your body, sleep, wakefulness, and emotions. So those are the part of the movement of the body. Basal ganglia consists of neurons that regulate walking, whether walking slow or fast. It's due to basal ganglia. Limbic system on its own comprises of structures like hippocampus, amygdala, septum, limbic cortex that regulates motivated behavior, emotions, and memory. You see here as well emotions. Here as well emotions. So make sure that you see the similarities, because you might confuse in the multiple choice questions and say choose the most correct. Midbrain, we have septum and segmentum. Under septum, we have superior collicus, a reflex center for controlling eye blink and the size of the pupil. A reflex center for controlling eye blink size of the pupil. Inferior collicus control volume or startling response to sound. You see how similar it is. We mentioned occipital lobe and said occipital lobe is for visual. So don't confuse the structures. Make sure that when you study, you write it down, you draw in order to make sense to you. Septum regulates motor movement. So under hindbrain, the key structures, medulla oblongata, pons, and cerebellum. Medulla oblongata, as I've said, is the most important structure in the brain. It determines life and death, thin line between life and death. The reflex sensor for survival, heart rate, and breathing. So if your breathing stops, your heart rate stops, you won't be able to live. They are regulated by the medulla oblongata. Pons, they regulate sleep and wakefulness. Hypothalamus is a state of sleep and wakefulness. Cerebellum coordinates motor movement. Segmentum regulates motor movements, coordinates motor movements. Check the difference between the two. The textbook will give you much detailed explanation. The brain, like I've said, the brain contains bumps and grooves. That's the structure of the brain. The brain is not smooth. It contains bumps and grooves. It's an outer layer. Then we have the left and the right hemisphere. Our brain is divided into two cerebral cortex, cerebral hemisphere, the left and the right. The left hemisphere regulates logic. It's for logic, rational thinking. The right hemisphere is for creativity. So in between the cerebral cortex, what connects the two hemispheres is corpus callosum. So the corpus callosum makes sure that the hemisphere don't meet. There's no clash between the two hemispheres due to this stick bone, which is corpus callosum. Acts as a bridge between the left and the right hemisphere. Then what protects the brain? The brain is called, the skull and the brain is filled with the fluid called cerebrospinal fluid. Cerebrospinal fluid to avoid the brain needs to float between the skull, within the skull. The brain needs to float and not attach to the skull. That is due to cerebrospinal fluid. In short, imagine the brain. Inside the brain, you open the skull, then you pour cerebrospinal fluid so that it won't attach to the skull, or there will be a movement. It won't be damaged as well. What produces cerebrospinal fluid is produced by the brain. It's produced by the brain. Also protected by blood-brain barriers. It's also protected by blood-brain barriers, as well as blood vessels. Those blood vessels are called what? Capillaries. Those capillaries are impermeable to important substances like oxygen and glucose. It's more like a sponge. Those capillaries ensure they're impermeable to important substances like oxygen and glucose. So when Jolene asked the question, when you receive information, not when you receive, when there's an intake of oxygen, even in our body, we breathe in oxygen, we take out carbon dioxide. So carbon dioxide in this instance, we say it's harmful substance. We don't need it to breathe. It's a harmful substance. And they say transport waste products. So oxygen comes in through the capillaries since I'm permeable. Then something needs to go out. Glucose, when it comes in, everything, the fluids, to a certain extent, they need to go out. When you transport information through the neurons react. There are chemicals that are released. Those chemicals, when they release, they need to go out as well. That is through those that transport waste products from the brain cells. So this I won't explain it. I've explained it already, and Jolene assisted. I will continue with the last part. The last part, peripheral nervous system. So central nervous system is the longest part. Peripheral nervous system is a bit short, divided into two. Somatic nervous system as well as autonomic nervous system, which determines the regulation of the neurons and the organs. Somatic happens internally. Soma, another word for soma is a body. Somatic, so it happens internally. Somatic nervous system refers to the nerves that conduct information from the sensory receptors in the body, to the central nervous system. Remember, central nervous system, the brain and spinal cord. Through this process, sensory or afferent. From the brain and spinal cord, central nervous system, to the skeletal muscles. That's where you react. Your body reacts. For instance, I can feel right now that I'm hungry. The first indicator will be hormones. Certain hormones will be released in my body. Then I know I'm hungry now. The brain will, certain hormones are released in the body. Those hormones sends information to the brain via the spinal cord. That what is it? The brain thalamus will indicate this is hunger and send information to the right part of the brain. Again, the information moves via the spinal cord. As soon as it moves via the spinal cord, goes back to relevant muscles, relevant organs in the body. Perhaps the stomach to say no, the person is hungry. Then I react. How do I react? Perhaps I salivate or I go to look for food. Autonomic nervous system controls the process that regulates internal organs, glands, so that the body functions evenly. When you see something that excites you, whether it's danger or something that gives you joy, internal organs and the glands react. Whether its heart rate is high, like they say, pupils of the eye, the movement. This happens through this process: sympathetic nervous system and parasympathetic nervous system. Paralyzes, that's where you come down. Sympathetic is more of a reaction. Excitement inhibits. Under parasympathetic nervous system, pupils of the eye allow more light. Pupils of the eye dilate to let into more light, more like you're shocked. I made an example of that emoji from WhatsApp. They open the eyes wide like that. So more light is in. On my right hand side, parasympathetic limits light from entering. That's where we are more relaxed. Under sympathetic, the structure of the lungs expands to absorb more oxygen, whereas parasympathetic decrease lungs. Lungs are more relaxed. Heart rate is high, is faster, blood pressure rises. Whereas on my right hand side, under parasympathetic, reduces blood pressure and heart rate. Sympathetic, more blood reaches the muscles to increase the supply of oxygen. Whereas here, muscles relaxes because nothing is happening. Less blood is available to the skin, digestive organs, so that more is available for the brain and the muscles. Blood pressure to the skin is restored in this case. Okay. Thank you very much. I hope I've answered your questions.
I see. Sorry. No, I have questions about last week. This is clear to me. I don't know what if the other student that asked the question, if she's clear on this.
Okay.
Okay. I've been working on old exam papers, and there's one question about in an October-November exam of 2018 about the refractory period.
Okay.
Now I know the refractory period is when the membrane returns the sodium and the potassium to the original state.
Yes.
But it is also possible to have a very intense stimulus at that stage, or is it not?
Under refractory period.
Yes.
No, there's no stimulus. Remember, the body is not the neuron is trying to go back to the neutral state, the normal state.
Okay.
But the sodium needs to go outside, the potassium goes inside. In that period, no movement that is taking place. No message can be received. Instead, the body will make use of other neurons.
Oh, all right. Okay, I understand.
Yes.
Okay, great stuff. And then I just want the other one. I would just like to confirm that I am correct with this one. When the resting membrane occurs, the sodium is positively charged on the outside, potassium are negatively charged on the inside, and the total electrical charge on the inside is negative.
Please repeat the question.
So when the resting membrane occurs,
yes,
the sodium on the outside is positively charged, the potassium on the inside is negatively charged, and the total electrical charge on the inside is negative.
Oh, okay, I think
is that correct? Am I understanding this correctly?
Oh, that's not a question, it's a statement.
Yes, but no, but the question is, am I understanding this correctly? Is that correct?
It's correct to a certain extent. It says, remember, you receive information. For information to pass through, for a nerve impulse to fire, you need a resting membrane potential. What will happen as soon as you receive information before the impulse can fire? Resting membrane potential determines the readiness of the neuron. How does it determine the readiness of the neuron? Then that's where the reaction comes into place. And normally, sodium is outside and potassium is inside. As soon as the neurons is ready to fire, the vice versa happens. Sodium goes inside, the potassium goes inside the potassium to make it positively charged. Sodium goes inside the potassium to make it positively charged. That will happen until it becomes overstimulated. As soon as it becomes overstimulated, the vice versa happens now. Potassium forces itself to go outside. Is that clear?
That's clear. Thank you so much.
I'm done with PYC 1501. Next week we'll be discussing sensation and perception under PYC 1501